In this lecture video, let's take a look at how we can solve what is so-called the elementary exponential equations. Okay, so these are very, very basic exponential equations that I want to solve before we start doing the application of exponential equations. All right, so the idea here is this thing called the base exponent property. So if I have a base A, okay, that equal to each other, then what I can do is set the exponent equal to each other. Okay, so when the base are the same and the base are equal, then we can actually set the exponent equal to each other so we can actually solve. So let me show you real quick. So I got this exponent, I got this variable on the exponent. So the idea is to make the base the same so we can set the exponent equal to each other. So here I only got two terms in this equation. So I'm going to move my negative 64 over. So that gives me 4x equal to 64. So if I can make this base, okay, if I can make this base the same as 4, then I can set the exponent equal to each other. Well, it just turns out if you try it, 4 to the second power is 16. 4 to the third power is actually 64. So the 64 can be rewritten as 4 to the third. So once the base are the same and the base are equal, we can set the exponent equal to each other. Therefore, x equal to 3. All right. So when we use the base exponent property, what we want to do is be able to make the base the same. Just like this one on the right. Okay, 2 is a base. Can I make 4 into a base 2? Well, so 4, okay, can be rewritten as 2 squared. Since there is a negative 4 on the outside of the base 4, then on the outside of my 2 squared, there should be a negative 4 power. So according to power rule, then this is going to be 2 to the negative 8. All right, according to the power rule of exponent, it's going to be 2 to the negative 8. So I was trying to look if we did any review, trying to see if we did any review on the exponent. So I don't want to name off things that you probably never heard before. So let me just double check real quick. I may not have gone over it. Yeah, I did. It's under the objective number 8 for the review. All right, so back to our problem. So this is now 2 to the x squared plus 7x equal to 2 to the negative 8 power. So when the base are the same and the base are equal, then we can set the exponent equal to each other. So now what I'm solving here is a quadratic equation. So I'm going to move my negative 8 over. And I get x squared plus 7x plus 8 equal to 0. And I really can't factor this because I can't add them up, give me a 7 here. Factor of 8 cannot add it up to equal to 7. So I know I got to use quadratic formula. So that's x equal to negative b, which is negative 7, plus minus square root of my b squared minus 4 times my a times my c, whole thing over 2 times my a. And I believe that's going to be negative 7 plus minus square root of 49 minus 32, which is 17, and whole thing over 2. And that's my answer. All right, to check it, what you can do, which I'm not going to do it right now, what you can do is take your answer, just do a plus or a minus separately, okay? Plug it in here and see if it's equal to 2 to the negative 8. Excuse me. See, plug it in here, see if it's equal to negative 8. If it is, then I confirm that's my answer. All right, this one here, let's make the base the same. I like my 2/3, but 27 over 8 is not quite 2/3 yet. So, but if you actually look closely, 27 is actually can be rewritten as 3 to the third power. 8 can be rewritten as 2 to the third power. Okay. So, if I'm thinking about power rule backwards, okay, power rule normally tell me to multiply my exponents. Okay. So if it's backwards, it's almost like before you multiply. So let's just kind of push these exponent 3 to the outside of it. So that can actually give me 3 over 2 to the 3x power. Okay, it does kind of make sense. Okay, it does kind of make sense. Let me kind of give you another example here to kind of explaining this concept. Why am I allowed to move it out? Okay, so if I have like x to the fourth power, x to the fourth power can be rewritten as x to the fourth whole thing to the first power, x to the first power whole thing to the fourth power. Or I can write it as x squared whole thing to the second power. Okay, so because I can write x to the fourth as x squared whole thing to the second power, that means this 2, okay, can actually be pushed back outside to become x to the fourth power. So it's so that's what I mean by backwards a little bit. Okay, we normally multiply. All right, but if you think about how many different ways we can write the exponents in terms of write them as in power rule kind of form, then this is actually makes sense. I can rewrite my 3 over 2 to the I can write my 28 over 8 as 3 over 2 to the third power. Now the x is already on the outside, so that's why I have to write x. 3 over 2 is not quite the same as 2/3. Okay, so to make 3 over 2 into 2/3, I will have to flip. So that's where the negative exponent come from. If the 2 need to go to the top, 3 need to come to the bottom. So since both bases is going to flip, that means they will all have an exponent of -1. So that should be 3 to the -1, 2 to the -1 on top, whole thing to the 3x power. So now, if I actually push the -1 power back outside, my 27 over 8 to the x power is really 2 over 3 to the -x power. Okay. So now I make the base the same, so I can set the exponents equal to each other. So this is going to be 3x. Oh, sorry, not that's -3x. Sorry. All right, move the -3x over, that become positive 5x. Move the positive 2 back, which is -2. My answer x equals -2 over 5. All right, try this one. This is a very interesting one here on the right side. So it's kind of obvious I need to make the base 3. So 243 using base 3. I know 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. Okay. So this is 3 to the fifth on the right side. Okay. So when the base are the same, according to product rule, when the base are the same and the base are multiplying, we will actually add the exponents. Okay. When the base are the same and the base are multiplying, we normally add the exponents. Now, that is actually true, but what I'm thinking is, let's just write it that way. If we add the exponents, that'll be 2x plus 1, then plus x. All right. When the base are the same and the base are multiplying, we can add the exponent. So I just write them together as addition. So this multiplication now become this addition right here. So if I will simplify the top a little bit, that gave me 3 to the 3x plus 1. All right. So now when the base are the same and base are multiplying, I can set the exponent equal to each other. So this is going to be 3x equal to 4, x equal to 4 over 3. There you go. Okay. When the base are the same and the base are multiplying, we can add the exponents. So in other words, we don't do this a lot. But sometimes you can say, okay, this is 3 to the 2x plus 1. Can I rewrite them as 3 to the 2x times 3 to the first? Yes, you can. That's actually still the same thing. Okay. So I'm using that idea of base are the same, which is product rule for the exponent. When the base are the same and the base are multiplying, we can always add the exponent. So this multiplication becomes that addition of x. All right, so that's 4/3. Now this one is interesting, okay? I got 1 over 6 for base, and this is a square root of 6. I know square root of 6 is the same as 6 to the half power. So now the question is, okay, do I want 6 as a base or 1 over 6 as base? So if I go with 6 as a base, that means this 6 right here got to be flipped to the top. So once it flip, then I will actually have a negative exponent. 1 over 6, if I flip it back to the top, that becomes 6 to the negative 1 power. So since I already have an x minus 3 over 4 on the outside of it, then we can push this negative sign back out to the exponent. So that will give me 6 to the negative x minus 3 over 4. All right, so when the base are the same and the base are equal to each other, we can set the exponent equal. All right, so let's multiply, okay? I'm gonna say the negative sign go with the top. Negative 2 times the top is 2 times the top will be negative 2, right? This negative sign go with the top. So that will be 2 times negative 1 times x minus 3, set equal to 4 times 1 is 4. Distribute, that will be negative 2x plus 6 equal to 4. Okay. So that will be negative 2x equal to negative 2. Put the 6 over, x is equal to positive 1. All right. So the idea here for these type of exponential equation is making the base the same. If I can make the base the same, then I can set the exponent equal to each other and solve it accordingly. Now we are going to learn about what happens if the base cannot be made the same, later on in a different video. All right, that will conclude this video on solving elementary exponential equations. Thank you for watching.